So what understanding the magnetic field leads us to is this concept called polar wandering. And this is something that confused geologists for a little bit, but in understanding what polar wander is and the artifact of polar wander is what helped us understand that the continents move. So let's see if we can work our way through this. So as I was talking in that last little lecture, if we trace out a continent's position over time, the magnetic information might show us different locations of magnetic north. For example, let's take a look down here. So if we take a look in our rocks, right, we have our magnetic information. And it's going to go back to 600 million years. So 600 million years ago, you see that magnetic north was in this direction. And you see that we're relatively close to the equator, right, because my compass is, it's not completely parallel, but it's pretty close to parallel. Now let's go forward in time at 500 million years ago. Magnetic north is now in this direction, and you see my continent is much closer to the pole, right, because it's at a higher angle. 400 million years ago, right, the north is in this direction, and it's even closer to the pole, right? We're probably almost on top of the pole because my compass is almost up and down. 300 million years ago, north is in this direction, and we've moved away from the pole a little bit. 200 million years ago, north is this direction. We're getting back towards the equator. 100 million years ago, there we are. There's north. We're getting closer to the equator again. And today, that's where magnetic north is, and we're almost on top of the equator. So if we're to take this information here and map it out, okay, what we have is this red line here, right, using this inclination and declination. We can say, okay, well, 600 million years ago, my continent was roughly located right here, right, closer to the equator. And 500 million years ago, right, we got closer to the pole, right? So we can use that information just like a GPS, right, basically telling us where we are. So if you look at this, right, as you can see, this is relatively confusing. What this makes it look like is my pole has moved over time. And that's what we call polar wander, right? Because remember, geologists thought that our continent stayed still. So if my continent stays still, it's recording the north position, right, in these spots. So like I said, this definitely confused geologists for a while. Now, what's even more confusing is when you take a look at other continents, they all have their own polar wander path, right? So, for example, right, this path over here on the right-hand side is Europe. Over here on the left-hand side is North America from 600 million years ago to today. And you see they kind of have a similar path, but they're in physically different locations. So how could that be, right, that my pole is in two different locations? So what geologists were seeing means one of two things. Either, right, and this is what's depicted here, either the continent stays still and my pole wanders over time, or the pole stays still and my continents wander through time. So again, like I said, this perplexed geologists quite a bit. But let's think about this. What's going to be more plausible? Is my continent going to move or the North Pole going to move? Well, the poles don't really move, right? They stay where they are. So this was that first bit of tangible evidence that made people realize, okay, Wagner wasn't crazy. Maybe Wagner was onto something. So we're going to use this idea now, then to go take a look at the sea floor. So in the next section, we're going to take a look at the ocean floor and the clues it reveals, and then we're going to tie all of that together, right, to come up with plate tectonics.